Hi, I'm Lance Culver, and this is going to be a beginner's level 3D Studio Max and TyFlow tutorial. I'm going to be building upon my last tutorial where I used TyFlow to simulate particles pouring into this object. In this tutorial, I will fracture this object and have those particles pour out. If you're new to TyFlow, this is a super simple setup. Just uses a few additional operators than the last tutorial. I have the jar from the previous tutorial, which is available in the description for download, and I have a model with a UVW map applied to it. We can go ahead and get right into setting this thing up. Go to Create, Standard Primitives, Box. Create a box out here like this. And drag it in until it makes contact with the object. Turn on Auto Key and set a keyframe. You can drag that keyframe over to around 80. And drag this box out of the way here. Select that keyframe and move it over to about 70. Hold Shift, drag it over to 90. You can turn off Auto Key. Just to keep things organized here a little bit, maybe rename this Activate. And hold the Shift key, select the box and drag it back just a little bit here, and we can rename this Fracture. Okay, one more thing here, go to Create, Standard Primitives, Tube. I'm going to create a tube around this jar. Just have it covered about like this. And zero it up with the jar. We can rename this Exit. Let's go ahead and shut these off. One more thing here, go to Helper Objects. You may have to click on this drop down, select Tie Icon, put one right here in the center, change it to a circle. Reduce the diameter to about 20 centimeters. Can lift it to about right here. Okay, that's pretty much all the initial setup. We can go over here to Geometry, select TyFlow, go over to Modify tab, Open Editor. Birth objects. Pick the jar and turn the jar off. And turn it into a PhysX shape. We switch to kinematic. Then we will do a surface test. Search for Activate. Change the search type to Shape Radius. Drag out a voronoi fracture into a new event. Connect it to the surface test. Change points to 75. So we drag out another surface test. This time pick the fracture object. New voronoi fracture. Connect it to the surface test. PhysX Shape to a new event. Connect it to the voronoi fracture. PhysX Collision. Pick the fracture object. It's maybe going a little too high, and we could adjust that by lowering our objects, but we can also go into surface test here. Select the distance, lower that down to, let's say, 8 centimeters. Rename this to jar. Birth operator. And this on 30 frames. And to begin with, about 2,000 particles. Let me shut this off right now. Can bring in a position icon. Let's pick a Ty icon. Shape. Pick the model. Add selected. Remove this. They're coming in as just spheres. So let's drag in shape. Uncheck this. Reduce the Z-axis to about 45%. Rotation. Drop in. Let's use particle physics. Uncheck integrate into bind solver. Turn the effect to position. Bring out speed. We'll change the direction to a long icon arrow. Pick the Ty icon. Use send out. PhysX shape. Connect it to send out. And turn on the jar. You'll notice how this is initially set up here. It's the properties under PhysX shape. You can change the hole type to mesh. That will resolve this. Property test. We're going to look at the velocity magnitude. And if anything is beneath 0.01, it will be sent into a new event. Well, it will be switched to kinematic and had a stop operator applied to it. So what we're doing up into this point is we're filling this object with particles. And as soon as they get beneath a certain velocity magnitude, we're bringing them to a complete rest with these two operators. Let's increase this to 6,000. But at a certain time, designated where we set up our fracture, frame 80, we want change the test type to frame, and we will use a PhysX switch to turn them back to dynamic, connected to the time test. Okay, we can do a few things here. Before we go any further, we can go into PhysX shape under the particles, under dynamics, and we can change turn this down here, change the static friction here down to 0.02. Can also change dynamic friction to 0.01. And this does just as it says, it reduces the friction on these objects. You can come down here under velocity limits and reduce the impulse to 1000. Change exit to 100. Also under PhysX Shape here, for the fractures, under Dynamics, we can increase angular damping 0.08. This will make sure that there's not too much spin, and also lower the exit to 500. And once some of these particles have made it out here, we no longer really need them to be activated. So we can use a surface test and pick the exit object. Let's do that right now. Let's see. Change the test type to volume inside. And now when particles exit the jar and pass through this tube, can send them to a new event where there'll be a property test. Do a test type of velocity magnitude, 0.01. PhysX switch, set to kinematic, connected to the property test with a stop operator. And now when the particles come out, they get so far, no longer need forces to be applied, we can basically turn them off. I'm not going to go over in this tutorial setting up the material, because I did that in the previous tutorial, but I will we will briefly go over the setup. I have a multi-sub object containing the materials from the previous tutorial, along with this glass material. So for these particles, we would set it to random, 1 through 5. And then for the jar, we would set it to static, value 6. Now to resolve some of this poke through, can increase our time step to 1/4 frame. I'm going to scrub through here. Well, I mean, that's pretty much it. We could increase some of these settings, the simulation sub-steps, position and velocity iterations. These would help reduce jitter, but that's not too bad there if you plan on rendering this. Drag on a mesh operator in each one of these events. Well, that's going to do it for this one. I really appreciate you taking the time and watching the video. I hope you've learned something. If there was any part of this that you didn't quite understand or that was giving you a problem, feel free to drop a comment and I will see if I can help you figure it out. So take care, have a wonderful day. I will see you in the next one.